I'm going to go through the 5.3 quick check. So starting off here, over on the side, we have kind of a nice picture here of a precipitate that's forming a double replacement reaction, so that there were, two chemicals here, and then in the container, and then there's another two chemicals in the test tube. So when they mixed, we made new combinations, that formed a precipitate. So here we go. Solutions of sodium sulfate, calcium chloride are mixed. Our first step is to go back and write in the ions. So I have Na plus and SO4 2 minus. And I have calcium chloride, Ca2 plus and Cl minus. Okay, so the first thing is what are the original combinations. So if I have Na1 plus SO4 2 minus, I'm going to have Na2 SO4. And I have calcium chloride, so 2 plus and 1 minus, so I have CaCl2. And if I change partners, if I put the Na and the Cl, I'll have NaCl. And calcium and sulfate, write the positive one first, so CaSO4. That's a 4. And now we go through, okay, well these are solutions. So since they're solutions, then I know these are AQ. But I could also look them up in my chart, and if I look up the sodium and the sulfate, calcium and chloride, again, they are going to be AQ. If I look up NaCl, now the thing again is there are a couple of these you really don't have to look up because they are always, always, always aqueous. So if you see sodium, if you see potassium, if you see ammonium, okay, if you see nitrate, and usually acetate, okay, those guys are always aqueous. You can look them up, but you can save yourself some time. So like NaCl is definitely going to be aqueous. So somebody here is turning into a solid, so it must be the calcium sulfate. So that is our reaction. Now let's just balance. I have 2 sodiums on this side, so I better put it 2 here. That gives me 2 chlorides. I have 2 chlorides, calcium, calcium, so this is balanced. Okay, so 1, 1, 2, and 1 is our balanced equation. Okay, solutions of potassium hydroxide and aluminum bromide. Okay, so potassium, K plus, hydroxide, OH minus, aluminum, Al3 plus, bromide, Br1 minus. Our first compounds, K and OH, just be 1 and 1. Okay, aluminum and bromide, 3 plus and 1 minus, so I'll need 3 Brs. Okay, and switch partners. My aluminum and my hydroxide would be Al, OH taken 3 times. And K and Br would just be KBr. Now, this time, let's go ahead and balance before we get started. I have 3 hydroxides on my right side, so I'm going to put a 3 in front of my potassium. If I have 3 Ks, I'm going to have 3 bromides, and I'm all done now. So I have 3 bromides, 1 aluminum, 1 aluminum. This is balanced. Okay, for states, I have solutions of these 2. So if I look it up, I would say, well, here's a potassium anyway, so I know that's going to be soluble, but it says solutions of these, so I know these are soluble. And of my 2 products, again, here's potassium, so I know that this is aqueous, so this one must be solid. And again, I could look it up in my chart to be sure, but this is the right answer. Okay, now, just going from the chemicals, okay, we say here's a compound, ionic compound, ionic compound, so we can, come with our products, but we're still going to do that first step. So Sr is 2 plus, okay, I is 1 minus, K is K plus, PO4 3 minus. So that part is okay. Now we're going to switch partners. So the strontium and the phosphate, 2 plus and 3 minus, so I'm going to need 3 of my SRs and 2 of my phosphates. And the K plus and I minus will go together. I'm going to get Ki. Remember, we always put the positive one first. So I already have aqueous and aqueous. So again, here's potassium, and I know potassiums are always aqueous, so this one must be the solid. We could balance now. Here I have 2 phosphates, so I better put a 2 in front of my K. And that gives me 6 potassiums, 2 times 3, so they must have a 6 in front of here. Now, if I have 6, here I have, I can't read my writing. This looks like a 3 in front of my strontium, so there must be a 3 in front of here. Double check with our eyes. 3 times 2 is 6 iodines, and here I have 6 iodines, so this is balanced. Okay, the last one, lead acetate and aluminum chloride. So I'm going to switch colors here. So Pb2+, and acetate C2H3O2-, aluminum Al3+, and chloride Cl-. So those compounds are already put together. The new combinations, if I put lead and chloride, I'm going to have PbCl2, and I'm going to have aluminum, so Al, and I need 3 of my acetates, so C2H3O2, taken 3 times. Now, acetates, we said that's one of our ones that are always aqueous, so we could look it up on our chart, but it's going to be aqueous. That means the lead chloride must be the solid. Now let's balance. I have 3 acetates, and I have 2 acetates. So I'm going to get that to balance first. So I'm going to put a 2 in front of my aluminum acetate and a 3 in front of my lead acetate. That gives me 3 leads. I need 3 here. I have 2 aluminums. I'm going to have a 2 there, and everything is balanced. And that's how the quick check works.